Okay, today I'm going to do functions as a service, serverless functions, and serverless containers. If you haven't seen the channel already, there's some modifications to this. This is like my worst part of this course because everything is changing in the labs because stuff changes in the cloud quite often. So if you could follow some of the, I'm trying to update the lab write-ups to be a little bit more accurate. But yeah, if you run into an issue, like for example, the issue that came up this morning was that the vulnerability that I had wanted you to see has been patched by Google. So Google gets a biscuit, but then my lab doesn't work anymore. So that one, just finish the lab as intended. You'll see something different than I had intended, but you can still read the article and see what the vulnerability used to be that would allow you to get your credentials compromised. So I'm going to continue with serverless infrastructure. We did platform as a service last week. And that was good because your homework this Saturday is a serverless app engine app with a serverless backend, serverless front end. So then you're basically only paying whenever a person comes and visits your application. So serverless functions, or functions as a service, of course that doesn't work. So if you recall, platform as a service, you treat the servers and the computation like electricity. It's a commodity that you consume on demand. You don't have to worry about a virtual machine or a container at all, unlike the previous labs. And these resources that are required to support your application are automatically scaled up. And this, if you are building a bunch of microservices on the back end, and these microservices are very infrequently used, then this is the cheapest way to do that. Because then, if they're idle long enough, they just get swapped out to disk effectively. Functions as a service is a special case of platform as a service. Rather than making the application serverless, you are making a function serverless. So it's done at a finer granularity. And typically, if you have a one-shot thing that you want to do, and you want it to be done serverlessly, you would use functions as a service rather than build a full-on app. So that's what we're going to talk about today. So with functions as a service, it typically consists of two things. A trigger, some kind of event that happens that spawns off this function, and then some code, a single function to run whenever that event happens. So the abstraction is whenever an event happens, just run this particular piece of code. This is sometimes referred to as internet glue or HTTP duct tape, because you're basically using these functions to tie one part of your application to another. And at the very end, we'll show you some deployments where you can see the duct tapeness of a function being used. Okay, I wish this thing worked. Oh, I had to turn it on. Okay, so another way to look at this is a functional programming approach to the cloud. Typically, when you deploy a function, you're not allowed to store any state, because this thing is going to scale up. And if you have 5 or 6 different instances of underlying containers running your function, you can't rely on being able to store state in that function and then be able to get it back at that state afterwards. And so what you're doing when you're creating a bunch of functions as a service is you're creating both basically mathematical functions that you can compose easily. So almost all of these functions are stateless, and if they do store state, it's typically done to a back-end like data store service, just like your homework. So in this is what side effects are being pushed out to the edge means. The edge meaning maybe a database backend is storing that state that you need to get it out of the function itself. Okay, so one example use, if you recall the idea of single-page applications, these things are great except when that first page load happens. You have to download the whole thing, right? And moreover, there's a bunch of client-side JavaScript in that single-page application, and that thing search engines hate. Search engines hate doing that. And so we talked about how one approach is to pre-render the entire site and ship all the static CSS and HTML into your CDN, and then allow the client on first access to hit all those static assets, and then in the background, the single-page application is going to load. So you could use a function to do that pre-rendering. And you could pre-render periodically, say every hour, I want you to pre-render and ship out to the CDN, or you could do it whenever the developer has pushed out a change into the production pipeline. So if you're doing a DevOps thing and then that final deployment happens, you can use that as a trigger to kick off the pre-rendering operation, and that would also automatically push the new assets out to the CDN. So this is just bringing back some of the things that we covered earlier. This is how you would operationalize some of that stuff that we talked about in the web dev lecture. Okay, some other use cases. Perform speech to text when requested. So Alexa, turn on the TV. That turns into probably an AWS Lambda, a function that gets triggered, and then that will spawn off the speech to text function. Another one is you have a game. Update the high scores of a game app. So as soon as the score changes, as soon as someone scores in the high score, that will trigger the thing to update the content of the website. Run fraud detection. So anyone sign up for a credit card account or a new bank account, you can run all of your fraud detection code as a trigger off of a new sign up rather than doing it periodically. This is becoming popular. We have deployed a whole bunch of sensors everywhere in our physical environment, and they're reporting data back. So when you get new readings from some kind of IoT device, then you need to wake up something in the cloud to ingest that. Typically, it's something in the cloud that's going to process all of that stuff to create a data product. This would be done as a trigger via a function. Another one is to transcode a video or blur an image when uploaded by a user. So this is what your lab is doing. So YouTube, someone uploads a new video. As soon as that thing is done uploading, it has to transcode it into multiple resolutions so that people from different kinds of devices can hit different resolutions. That would be done as a cloud function. And then another one, which is also your lab, is to run a Slack bot. So if you know the Slack slash commands, if you do slash command something, Slack will do something for you that's similar to IRC. So in this case, you're going to implement a slash command that when someone uses that command, it will spawn off a request to an HTTP trigger that will invoke a function. And that function will do some kind of knowledge graph search, which I'll walk through later on today. Okay, so some broader patterns. This style of operation is basically how all of these API services and all of these managed cloud services on the back end are implemented. They don't have clusters of long-running servers that are sitting there waiting for requests. They'll do it in this style where there are serverless functions that are waiting for a trigger from a user, and then we'll wake up and process that request on demand. So we'll be doing this next week, Cloud Vision, Cloud Natural Language Processing, the BigQuery at the end of the week. That's all done as serverless functions. And then as you start to beat the heck out of those API endpoints, it will spawn off more sort of instances to handle those requests. Okay. Another thing that it's good for is this ETL pattern, and this is something in data science. So I think we have a data science course that Kristen Tufte is teaching. ETL is something that's essential in any kind of data processing pipeline. It's extract, transform, and load that data into something that an analyst can look at. So this is where this is where sort of the data collection cleansing happens, and most of these things are done as functions. So you need some triggers, you get some new data, that new data is going to be transformed, and then that transform is going to end up inserting something into some database backend. Okay, so it's typically not used to implement the entire application, but you could implement an entire application completely with functions. And it was 2 years ago, I sat through a capstone project where the entire project was like a collection of 20 AWS Lambda functions. Their entire app had been deployed, and you can do this. You can make every single route a Lambda, a serverless function, and you'll see this in the lab. Well, eventually, we'll do the guest book as a serverless, a function-based implementation. But this is the idea. These are what are called JAM applications: JavaScript, RESTful APIs, and static markup. So the idea here, if you look at this, there is no web server really. You have this CDN that's serving files. Effectively, it's not running the Python interpreter or anything like that. You basically do your React or your Angular or whatever your client-side framework is implementing, and you deploy all of that JavaScript, CSS, and HTML as a bundle in a CDN. And then the client is just going to get that bundle, and then everything is built into that bundle, and that bundle is just going to make requests to these functions directly. And these can be HTTP endpoints. And so every route in your app could either be locally handled by your HTML and CSS locally, but if you need something that requires backend information, then you would just have this trigger one of these serverless functions to retrieve the data, or you could implement something that would go directly to the database. So there is no need to run a Python Flask here in the middle. Everything is done via REST APIs and serverless functions. Okay, so that's a model of deploying a website. I don't know how many people do this, but you can if you're interested in this pattern, you can click on that. So web applications without web servers is effectively. There's actually, obviously there's going to be a server here implementing all of this, but it's not a server that you as a developer get your hands on. This is something that Google's running or AWS is running. It's not something you can say, oh, apt install something onto this server. You don't get that with this style of operation. Okay, so production versions of this, AWS Lambda, Google Cloud, Cloud Functions, Microsoft has their Azure Functions, and then the open source version is called OpenWhisk. So if you're trying to run your own cloud infrastructure, you would use some of these open source packages. Okay, so I teach the security stuff here. So is this better for security? One of the advantages of doing it this way is that there is no server there for someone to drop malware on, right? It's not persistent. Like those things come up and down. So if someone does somehow subvert your function and, for heaven forbid, execute bin bash on it, it's not going to be able to do much. Whereas if you're running a Python Flask app, and someone can do an OS command injection on your app, they've got access to your physical server, your Apache or your Nginx that's running on the back end. So that's actually a good thing. But, whoops, wrong direction. There are some issues with security when it comes to serverless applications. And the one that I was trying to show you in the lab was that you often have some things that can be exposed via your serverless deployment. And one of the sort of the crown jewels of any cloud project are its API keys, or its access keys, its tokens. So this is something that if you have misconfigured your function, someone can get in there, exploit the function to dump any kind of credentials that are used to deploy that function. And so there are some references where there are some instances where calling functions and having your function share the same infrastructure as someone else's function allows you to basically compromise the neighbor function. And this is what this, if you Google this talk, this is what he talks about. And so there are several security problems with Lambda functions. There's this AWS Lambda CTF. We try and get at some of these things. So later on in your labs, there will be some issues that I'll have you walk through that look at specific security issues in the cloud that can show up. And then we're going to definitely give a good treatment of this so you can register for this I believe now, the web and cloud security class. So there'll be examples of compromising these serverless infrastructures in that class. Okay, the other big issue is that the response times aren't guaranteed. The way serverless functions work is that if you have a function that has been recently executed, the container that was used to execute that function stays around, right? So it's sort of like Docker start, and that thing is sitting there so that when you can do a Docker PS, it's there running. But after a while, if it hasn't received a request, that container will be brought down. So similar to doing a Docker stop. And then, if it's been idle long enough, it'll be brought down, and on the next invocation, you have to wait for the container to be brought back up. And this is on the order of a second. And so for some people, that's unacceptable. Like, you can't have a 1-second delay on some of these applications. So you would not want to build an app on these things if you really care about that kind of initial startup latency. Because that's the latency, that's sort of what you're paying for when you go to this sort of pay as you need model. Okay, so there is this interesting article that does a serverless comparison of all the different providers in terms of, how fast is it to go from a cold start to serving a function. And it's an interesting read, and I recommend. Hopefully the link still works. Okay. The other thing is that you have a very limited time budget. So on AWS, you have 5 minutes. So your function can't last more than 5 minutes, otherwise it'll get torn down. And the reason why this is the case is that all of these things are implemented on those preemptible VMs that I mentioned earlier, right? And this is how they get the cost savings, right? If I know I can reclaim that virtual machine on demand, then the people who are using that and assuming that that can happen don't have to pay as much. And moreover, the AWS Lambdas or the cloud functions don't have to pay as high of a cost just because I know I can terminate those functions and then get my server back to the high-paying customers. There are some disadvantages. The vendor lock-in is a disadvantage. You start building all of your triggers on either AWS or Google Cloud, and then all of a sudden it's really hard to move from one platform to another. And this is why, as the thing evolves, you'll see all these companies are having to manage Azure, AWS, and Google Cloud all at the same time, because when you're acquiring companies and companies have decided to use one platform versus another, the integration thing to move it all into a single platform is not worth the engineering costs. So instead, people are just sprawling all of their cloud stuff across multiple providers, and they're locked into those providers. The other issue is, in order to get the scalability to implement this thing, they have to make sure everyone gets the same container runtime. And this is similar to App Engine. App Engine's like, hey, I can do Node, I can do Python with maybe some Flask, but if you're going to use Django, forget it. You're not going to be able to build anything in App Engine. I don't want you on my platform. Maybe they support Django now. I don't think they do. It's basically Python 3 and then Flask is their container. And the reason why that is because everyone's got the same container on all of the App Engine nodes, so it's really easy to bring these containers up and down on those nodes. So custom runtimes are definitely more difficult to support. Okay, so you are going to be using Google Cloud Functions and AWS Lambdas in your lab. And so with Cloud Functions, the two runtimes that Google supports are Node and Python, which are the dominant two. But you'll see, I think in AWS Lambda, they have I think they have Ruby as well as I forget which other languages, but the language support is much better on AWS, but we're going to use Google Cloud Functions. So with Google Cloud Functions, all you're doing is specifying a single file. It's either a JavaScript file or a Python file, and within that you have a function, a single function that will be the thing that gets registered to execute when this thing is triggered. The other thing you specify is your package.json, which is all of the NPM packages that your function depends upon, or requirements.txt, which is all of your Python packages. And then the runtime, after you deploy this cloud function, is going to build that down into native modules to make it fast for both NPM and Python. And then this can be used to support functions in two modes. You can have a synchronous mode, which is sort of like implementing a REST API endpoint, where the function will run until the response is sent back to the user. That's synchronous. It could also do things synchronously, where you call it, and then it'll run in the background, and it will basically do a callback whenever the function is done. It'll call back to the app. So those are the two modes. We're going to do mostly the synchronous mode in your labs. Okay. So the next thing I want to talk about are containers as a service. So serverless platforms are typically implemented with containers, and they specify a restricted environment and a very particular environment to get scalability. And so the languages in App Engine, so for the standard, you have a restrictive set of containers, and then with Flex, you're allowed to customize that base container, which is like adding some layers to the base Docker image. So the serverless functions also have the same model. It's implemented with containers. They want everyone to standardize on a particular set of them, so they don't have to manage all of the different kinds of containers that people are trying to run. Okay, so serverless containers are bring your own container, right? If you build any container you like, it could run on any kind of language platform. It could do any kinds of library versions and whatnot. And so this is saying that you bring the container and then we'll implement it just the way we've implemented App Engine. And so with that, you're gonna basically run this container image serverlessly, where if no one is accessing this container, it will get put to sleep. And then if someone hits it for the first time, it'll bring that thing up. It'll bring the container up quickly and then process the request. Okay, so this is serverless containers. There are some things that are required to implement serverless containers. One is a container registry that's not public, right? Like if you put your crown jewels in a container image, you don't want to put it up on Docker Hub, unless, well, maybe a private Docker Hub, but even then Docker Hub had some security issues. You would typically want to keep your container image within the project. So not only is it a security concern, but from a implementation issue, it's much faster to pull an image from a repository that's stored in Google's infrastructure than for Google to go out to Docker Hub and pull it. So the container registry that's built into Google Cloud is gcr.io, and this is their hosted version of Docker Hub. And so it's integrated so that when you do a Docker pull and a Docker run or a Docker push, it's integrated into the Docker commands that you can point these things over to gcr.io rather than to Docker Hub, is the idea. The other thing that Google Cloud has is this container builder. And this allows you to build the container within the Google Cloud infrastructure. So you'll be doing both. You'll be building a container image in Cloud Shell and then just pushing it up to the registry. You'll also be using the container builder infrastructure, where you just supply container builder with a Docker file, and then a Docker file in your source code, and then it builds the image and populates the registry. So both methods will be in your lab for this set. Okay, so Google Cloud Run is their serverless container implementation, is Google's serverless container implementation. And so the idea is the same as before, where it replicates the container whenever the requests are high, and then it removes them when it's not being used. And the really cool thing is that now you can do this straight from a Git repository. So if someone has a Git repo and it's got a Docker file in it, then there's this little button that you can drop right into your GitHub repo that if someone clicks, it'll automatically build the container and launch it into your Google Cloud project so you can test it. So this is something that people are starting to put into their projects. Okay, so I'm going to have you do 3 Cloud Run labs just to give you some practice doing this. Okay, the next thing I want to talk about is distributed messaging, and this more relates to the Cloud Functions stuff. So there are these message brokers We talked about Apache Kafka before when we talked about the New York Times. And so the idea of Kafka is to create all of these message queues, and each message queue is associated with a topic. And then the way the producers of data and content push stuff is to sequentially push it to these message queues, and then the consumers can pull it off of that log sequentially. And so this is very natural when you're building data pipelines and data processing pipelines. It's very natural to use message queues and message brokers it's basically the pipes between the services in the cloud. So that's what these things are doing. And so anything that's a producer-consumer pattern, as we saw when I talked about the IoT example, would use a message queue. And then within the message queue, you can build a function, a serverless function that when there's something that gets added to that queue will trigger a wake up of that function to process it. And this is done using, in the case of Google, this Cloud Pub Sub. Amazon has Kinesis. It's got SQS, which is their simple queuing service. And then there's a service bus for Azure. And then we already talked about Kafka, which is the open source version of this. So this is just another Lego that you need in the cloud.
Is that where you would transform the data that you would get from IoT?
You would use this, you would send the data using a pub sub, and then this would trigger the transform operation. And I have a great end-to-end example of all of these pieces put together. And so yeah, these are basically, this is a kind of Lego to connect the ingesting operation and the transform operation. Because every piece of data, so I might have temperature data here and I might have parking spot availability data there. They're not going to want to trigger the same, they're going to have different topics. They're going to have different pub sub things based on the sensor ID, based on the type. And so they'll have different topics, and then those, putting a event onto that particular topic will trigger the associated transform operation and then continue the pipeline. Okay. This is more back-end stuff. So this is not web app kinds of stuff. This is more back-end data processing stuff, which is where we're going to move to towards the end of this class. Okay. So Cloud Pub Sub is Google's implementation of this. And it's typically used to pipe data and events between all of the different properties within the Google Cloud. And it's often used to trigger cloud functions. So the IoT example is the canonical one of that. Okay, so I'm going to put all of this stuff together, the message queue stuff with the functions, and talk about how these apps are done. So the first app is this GitHub integration on our Slack channel. So I don't know if you've seen this, but we have the GitHub bot on our Slack channel. And if you want, you can have that thing notify you whenever someone does a commit or pushes something into a repo that you're watching. And the way this is implemented, it's not Slack going and monitoring GitHub all the time. It's basically registering what's known as a webhook in GitHub. And anytime this this commit has happened, you can register set up your repository to notify a particular webhook that implements a cloud function. And this cloud function will then interact with your pre-configured Slack bot to basically send you a notification in the Slack channel. So this is how Slack is being used as a monitoring front end for all of your back-end cloud stuff. There's a ton of Slack integrations where cloud events generate something in someone's Slack client. And if your Slack is like mine, maybe you don't want that with all the messages that go across. Yeah.
There was a web app that came out a few years ago that I was using. It had like a French name, and they had routing for it connected to everything. You could do something to Excel. You could do it just like this: GitHub to Slack, or this to Twitter, or this to that.
Yeah.
That's all they did.
Mm-hmm.
It was like a French name for it.
Okay. If you find it, yeah, post it to the channel.
I will post
yeah.
it. What's that? I think that is. How do you spell it?
IFDD. All right.
No, that wasn't it. It was French. It was like.
All right.
sounds like IFTTT.
IFTTT, okay. Triple T, okay. All right. Here's another one, and this gets at what you were talking about. You would have sensors, and I have a bigger example next. You would have a sensor that would trigger an event if the temperature is over 80 degrees Fahrenheit. That would, so you've registered this sensor to IoT Core. You've like, hey, I want this to be part of an application I'm running on the cloud, so this thing manages all the devices. Well, this registers all the devices, so that's what IoT Core does as part of its setup, register devices onto it. And then this will then, you configure this thing for this sensor to generate an event on some topic queue that, yes, the temperature is above 80 degrees Fahrenheit. And this event will then trigger a cloud function based on the logic of what this event generates. And then the cloud function will determine whether or not it needs to do something. And so if it figures out that, yes, greater than 80 degrees Fahrenheit needs something to have happen, it can then communicate directly back to IoT Core to do the actuation. So this is the sensing part, and then IoT Core can do the actuation part, and then it basically turns the fan ceiling on as part of the actuation. So this is an example of just automatically turning on the ceiling fan when this temperature reaches 80 degrees Fahrenheit using a bunch of IoT sensors through this platform. Here's another one, a smart parking application. You have a bunch of, so this is similar to like the Portland airport that's got all those sensors. You would have all of these sensors registered, and this is a specific protocol for sending events over to IoT Core. And this is the ingestion step. And so the IoT Core does the sensor registration, and it does the security, and then it does the extraction. So as soon as this thing happens, this thing wakes up to do the extraction of the event. And then it figures out which topic queue to put this thing in. So it's doing the routing, event routing, because you have set up your application to respond to certain kinds of events coming in from your sensors. So then what would happen was, so you have an event queue per type of event, and then you would do the transform. So this is the ingesting of the events and then transforming it to do something. So if you want to, for example, create a graph of the average availability of spots over time, then maybe you can have a function that does that. Or if you actually just want the instantaneous state of the parking lot, you could have a different function for that. And so you could build all of your different data products on these cloud functions, and you would update them whenever your topic queue has data that would require your data product to change. So that's the idea. And you could just store, you could have another function just sit here and store the entire log into a database. So this Firebase database is basically Cloud Data Store or Cloud Bigtable. It's just a NoSQL database that's just really good at just storing a bunch of stuff, if you wanted to. And then what you could do is you could, as part of this, you could also, all of the data products that you eventually want users to be able to visualize, you could basically aggregate or transform the data into BigQuery, which is something that we'll use at the very end of this class, and then use some visualization tools in order to build your front-end app. And then this front-end app would be what your regular users, your non-technical users, would visit the site to see the parking availability data. Okay, so this is an end-to-end application that's using basically cloud functions on the back end. Are there any questions about this? You won't be building this in this class, but maybe if there's an advanced cloud class, we could build something that's like this. Yeah.
So if you want to like reserve a spot, instead of going to the cloud core, it would go to like the pub sub or something?
It depends on what reserving a slot would do. Like, what would you want this? Yeah, I don't know if maybe you could turn the light red, saying that the thing is reserved, or maybe if there's actually a barrier that can, an IoT barrier per spot that can then lift up. Then yeah, then what you would do is any UI interaction could then trigger the cloud function into IoT Core directly to actuate. So IoT Core is your pathway for sensing and actuating in your platform, and then that would be what you would have. Yeah, I don't know if I don't know if they implement that, but yeah, that would be pretty cool. Just turn the light red and hope that nobody parks there. But like, yeah, you would, yeah, I don't know. There's got to be someone who is doing that. Like, yeah, if it's really if it's VIP parking, then you could build an app that had a barrier that would just undo itself whenever. Yeah, this could be totally IoT driven, like, because then the IoT in the car, like if that thing has their GPS, and the event is your GPS in that car is near that spot, is anywhere near that spot, I'm just going to pull the barrier down, and that could all be done automatically using these this kind of setup. Yeah, if you wanted to. Maybe that could be a hackathon project for people. Okay, this one's a security one that I liked when I saw it. So it's similar. You have a bunch of devices, and this is actually, if you know Senrio, this is a startup company here locally. I think they have their office is next to the library downtown. But what Senrio does is they instrument the firmware of IoT devices, and what they're doing is they're taking execution traces, runtime execution traces of IoT sensors, and they're feeding it up into the cloud, into Google's cloud. Well, I don't think they're on Google, but it's something similar is being done on Google's cloud. And then what they do is they run machine learning on that. And they're like, oh, this particular sensor for the last year has had this style of execution. And then when somebody compromises that device, then the idea is that, hey, I can use machine learning to figure out that thing has been compromised. So this is a system that they've sort of built doing this thing. So then you have your devices here, and they're basically uploading execution traces into IoT Core, through IoT Core, and that creates something in Cloud PubSub. So the event of uploading your trace creates puts a topic, or puts an event in a topic queue. And then what you can do is you can use that to trigger functions that kick off Cloud Data Flow jobs. And this is the last week of class. These are jobs where you can take all the data and process it through a pipeline. And then using this data flow operation, you can do, basically, you can ingest this. You can ingest the products, because maybe you don't want the full trace, but you want some statistics on the execution trace. And then after your Cloud Data Flow is done processing the trace, so this is where the transform is being done, you would then store it. You would load it into either Bigtable or BigQuery. And then from here, then you can run your machine learning to figure out whether or not this particular trace is anomalous from that particular device's previous trace. And then you can do all of this on the back end, and then this eventually you can push these models back into the front end to IoT Core to make your detection more accurate, and then you can do some visualization on the back end, is the idea for this particular app. All right. So with that, are there any questions about, that's all I have lecture-wise. What I'm going to do now is just walk through some of the labs. And this is something I used to do for all the labs, but for this particular class, I just haven't had the time. So I'm going to walk through. There are 3 Cloud Run labs, and I believe there are 3 serverless function labs. There might be 4, because I think there's an AWS one. So what you'll be doing is you'll be creating these files, create a directory, in Cloud Shell, create this directory. And then this is the app, and the app has 2 pages. It has this default page, which is Hello World, and it's got this special secret firewall bypass proxy page that it is basically going to serve proxy.html. It's going to run this thing on port 8000 unless you specify the port at runtime. So that's the app. It's really simple. Requirements, it needs Flask, requests, and GUnicorn. And then this is the proxy. And all the proxy does is it takes a URL as an input, and then it basically will update the item with whatever is in the href specified. So whatever is in this URL, well, this is actually the script that gets run. So if it gets called, it's going to basically fetch the contents of this URL and then set the window location to it. Okay. So this is the Docker file. It's really simple. Make sure you change the maintainer to you. Is the only thing that you have to do here. And then this is something that you probably know already. And then it's a simple Docker build. So you're going to build this container image, and then you're going to run it locally. So when you run it locally, it should come up on port 8000. And then you can preview this. So in Cloud Shell, when you do this, then in the web preview button, you can preview the app on port 8000. And then once you get the app running, you can stop the container, remove it, and then delete the image. Because what I'm going to have you do next is use that container build service to have Google Cloud build the same thing and then populate the container registry with it. So that is what this command is doing. So what this is doing is it's submitting all your source files to the container build service, and the container build service is going to run the Docker build stuff. So all of that stuff is going to get built, and you'll see this thing. It'll basically tar and gzip up your current directory and then just upload it to Container Builder. And then Container Builder is going to run the exact same thing and then push this repository, push the image to the container registry. So this is so you run this in the same directory as the Docker file, and then you say you want to submit it, and the tag, this would be sort of like the Docker Hub image ID. You specify that you want to store this on the local container registry using your project name. So this has to be your project name because the container registry is associated on a per project level. And then you just give it a name. And this name will have your Odin ID. When that is finished, you can go to the container registry UI to see that container has been built. You could do a gcloud container images list to show that registry is there. And this is the same thing as a Docker, what Docker Hub is going to do for you. And then you just deploy it. So this is the command that says, deploy the name, you're naming the deployment this, and then say the image I want to deploy is the same one that just got built. It'll ask you some questions, use Cloud Run fully managed, US Central 1, allow unauthenticated invocations, and then it will go and deploy that container serverlessly and give you a URL to run that when you click on this will automatically launch that container on their infrastructure. Okay? And then click the link that's returned. So that's this endpoint. And then you'll get this UI, and then if you go to your you'll get the hello world message, and then if you go to that route that you had that had a special URL, that will give you that'll allow you to do the proxy operation. Now, what I wanted you to see is that if you have a proxy here, one of the vulnerabilities that I wanted you to see are in these two articles. This is really dangerous to do on your cloud project. And so I don't want to give it away, but this is the last step, is to take a look at this. All your crown jewels for your project, for this instance, are at that URL. And so if you allow someone to inject a URL into something that you're running on a cloud project, and they can go and hit this thing with it, it's game over on your project. Or it used to be. It's still game over on AWS. It's not game over anymore on Google Cloud, because Google Cloud decided to fix this. And actually, this is what Ron Wyden is trying to get AWS in hot water with. He's like, why is this allowed? So if you've, like in the last month, he's like, AWS is the problem in this Capital One breach. It's not the Capital One people. So like, who's at fault when stuff like this happens? Wyden thinks that this is an AWS issue, not a Capital One issue. So it's just an interesting aside, because it's been in the news so much. Well, it's the news I follow, which is pretty geeky, but it's still been in the news. And then cleanup is the last step. Cloud Run Lab number 2. So I know some of you are in the full stack course. So if you want to do the exact same thing using a Node.js app, and you don't want to deal with AWS Lambda or Cloud Functions, this is a very natural thing for you to do. I have a Node application, a full-on Node application, and I just want to build a container out of it, and then serve that up serverlessly. And so this is an example. This is from the blockchain class. This is a GitHub repository that's got a Docker file for you to run this person's Node.js application anywhere that you want. So I'm going to have you clone this thing, and within this repository, there's a Docker file, and all you need to do is go into this directory and then do a gcloud build submit and create this thing. That's how easy it is. So if you have a Docker file for your Node.js app, this is all you need to do to get that thing to work and to create a serverless container, and then you deploy it. And again, just like before, set the services up, and then you can get something like this. And when you click on it, you can get someone else's Node.js application as a container running on Cloud Run. So that's, again, a nice way of deploying, just seeing what's in that repository, seeing if there's some functionality there that you might want. And this can be done easily. And this is why they added the click to deploy on Cloud Run in GitHub repos, because you're like, oh yeah, this looks like, I'm looking at the README, that looks pretty interesting. Let me just test it. And I can just click on one button and it does this for me for you to demo the thing. So that's actually quite powerful for developers, I think. Okay, and then cleanup, unless, this stuff is not going to cost a lot of money. So you don't have to if you're lazy. In fact, I had a whole bunch of them there, so yeah, it doesn't cost you that much. The last one, the last Cloud Run lab is to take your guestbook and run it as a serverless container. And so again, the Docker file is there, and then change the maintainer. And then also, because the backend is going to point to your data store backend, you have to substitute your project ID in model_datastore, as you did in the previous labs. And then you can, in this case, I'm going to have you build it locally. I could have used the container build, but for this one, I want to show you could do this locally as well. So you build it locally, just like before. You give it this label GCP guestbook. And then I want you to run this locally, just like the first one, to test it. And this is the command that you would run. Say, I want to listen on port 8000. Well, I want to send this variable, environment variable, inside the Docker container, so that the application inside the Docker container, the G unicorn inside the Docker container, will listen on this port. And then for the outer Docker, I want to map port 8000 on the host to port 8000 in the container. So that's what this command is doing. Configure G unicorn to run on port 8000, and then set up the networking. Give it the container a name, just GB, and then this is the container image. And then run it in detached mode, and then just like in the first Cloud Run lab, you preview it on port 8000, and you should see the remnants of your previous guestbook labs. The messages that you entered in there should show up, because it's the same data store backend. It's just being run, the front end is just being run in different modes. So that's what you should see. Sign the guestbook to show that it works, and then say this is Cloud Run in the dev mode, because you're running this in the Cloud Shell, which is the development server. But then I want you to stop and remove the container, and then I want you to deploy on Cloud Run. So I want you to actually run the thing. You'll get the URL of the running application. I want you to click on it, and then after you click on it, you should see the same guestbook, and then I want you to add again, so you see that this is the Cloud Run URL, but it's got the same old guestbook stuff, and then I want you to insert another entry that's the Cloud Run deploy message. So yeah, a different way of running the exact same app that you've been running all quarter. You'll be pretty sick of this guestbook app after a while, but whatever. I don't have the creativity to write anything more than that. And then you can clean up. You might not need to clean up after this, because then we're going to run this. We're going to run the same app using Kubernetes, and I think maybe you can save this container image. We might reuse it actually. Okay. The next thing I want to talk about are the serverless function labs. So the first one is the hello world of serverless functions. So I don't know if you have to do this, but enable the API. So for all of the API services, if you want to use them, you have to go and see if they're enabled. So on the left hand in the sandwich, the hamburger thing, you can go to the APIs and services and then see whether or not Cloud Functions has been enabled. And then you've already cloned this repository, so you go to this directory, and this is the hello world thing. And it's done using Flask. And this function, when this trigger gets called from HTTP, it will give you a Flask request object. And it will populate that request object with everything that the client has sent as part of its request. And then in this case, we're not even using anything from the request. We're just returning hello world in this app. There are other functions that are implemented in this file. So you could see different styles of triggers that have been implemented. You're just going to deploy this particular function. So you give it the name of the function in this file that you want to deploy. So this is at the function level. So this is where it will parse main.py and then pull out hello get when you give it something like this. G-Cloud functions deploy hello get. It's going to go into main.py, figure out what hello get is, and then you specify the runtime, and then that this is going to be called from HTTP. And then eventually you'll see the output that will give you the trigger that will call your function. Because we decided to make this a HTTP trigger, it's going to give us a URL to hit to execute that function. Okay. And then what you do is you click on that trigger, or you can curl it. And then you can curl it to see that you get hello world, and then you can visit it to get the hello world. Okay. And then finally delete the function. So this is just to get you the mechanics. And it's very similar to Cloud Run, right? Like there's not much difference between how they're deployed. Okay, so that's the first 10-minute hello world of Cloud Functions. The next one is an application that blurs offensive images that are uploaded to a storage bucket. So the first one ran on an HTTP trigger, but Cloud Functions can be run on any kind of event type, not just web requests. And so the one that I want you to run, it's also a tutorial. If you go into this directory, this image magic directory, before you run this code lab, you're going to have to create two buckets. One is an input bucket and one is an output bucket. So the input bucket's going to get some images, and the output bucket. So then whenever you receive an image on this input bucket, then that's going to trigger the function. And what the function is going to do, it's going to take the image that was uploaded and see if there's any offensive content in it. And if there's offensive content in it, it's going to call ImageMagick to blur it out so that it's basically kid-friendly. And then it will take that blurred image and then output it into the other bucket. So that's all this function does. So in order to do this is your first step into the machine learning APIs on Google Cloud. You have to enable the Cloud Vision API, because we're going to use this to determine whether or not the image is offensive. We're going to use the Vision API's annotation feature, and this is probably the best vision, because they have the most images to run their models on. So they have their models where you can give it an image and it will accurately detect things that you don't want. Is what this app is doing. And this is the code that does this. Much like you import Cloud Data Store, you just from Google Cloud, you import the storage and the vision packages, because you're going to need the storage to get the images to and from the buckets, and then you're going to need the vision to basically take a file, the file contents, and then query the Vision API with it. And that's done with this Vision package. And then you're basically going to use from ImageMagick, you're going to use this thing to do the blurring, this particular package to do the blurring. So the first thing is to instantiate a storage client, and then instantiate a vision client, and then we'll be using these two clients to do all of the work in this function. The trigger that you're going to register is blur offensive images, and the function is going to be given. So when you specify the kind of trigger, it will specify the kinds of things that are passed to the Cloud function. So when I specify the HTTP trigger in the previous one, it's going to send me the request, the Flask request object as part of the parameter for my Cloud function. When I say that this is going to be, this will be a storage bucket trigger. When this is a storage bucket trigger, it's going to give me this, the data and the context for the trigger. And then given this, as part of what I'm being passed, I can then say, well, get the file name and get the bucket name of the new image that has been uploaded. And that's sent as part of the storage trigger context in data. And then what I'm going to do is I'm going to create in this bucket, I'm going to access, sorry, this is the name of the new file. So this is the path to the new image file. And then I'm going to basically get that blob, the contents of that blob, into my program. I'm going to specify the URI as gs:// name and file name, and then I'm going to give it this, create this dictionary blob source. And I'm going to do this so that I can then detect whether or not this thing has an offensive image. So this is just setting up some bookkeeping information, is the next step. Okay. Note if this is foreign to you, this is the F-string syntax. It's sort of like a compact format string. This is a Python 3.6 thing. So this is just recently in 3.6 that this format has been sort of standardized. So I know some people were running into issues where they had Python 3.5 and this thing was completely breaking. If this completely breaks, it means that your Python version is one version behind. That's other part. So we'll get, I think, in the code later that it uses some of the context, or does it not? It's not germane actually to this. So yeah, it's not being used. Okay. So it's mostly the data that's being used. I think the context is other parts of the runtime that you're getting called with. Okay, so then, given that you have the blob, you can call the vision client. So the vision client doesn't want the entire data. All it wants is this thing. It wants this URI, and it wants this to be sent to it as a JSON object. So you send the vision client this thing, and then it will go and retrieve that blob and analyze it for you, and that's what this is. So vision client, and the API call is safe search detection. So this is what's running when you do safe search for your kids, for example. It's automatically going to filter out these images and sites that are inappropriate, and that's done with this API call to filter things out. And then it will pass back a JSON object. And as part of this JSON object, you get this detected field in the object that you can then see whether or not it's adult content or if it's violent content. And if these things score 5, which is the highest score, you'll be like, okay, I have to do something about this content. And in this case, the thing I'm going to do with this content is I'm going to blur the image. And then if not, then it's going to leave that file alone. Okay, so then what happens in this return image call? This is the blur image call. And what it does is it basically downloads from that storage bucket, because you gave it the blob information, you download that thing locally. And then what you do is you call the image magic. So we mentioned that import for the image magic tools. You call image magic and you say, I want to blur a radius 16 pixel around the entire image. It's like taking a big blurring eraser and then just going across the image with it. And you'll see that this is basically a radius of blurring that you specify. And then it'll create a new file, and then you're going to save that and then upload it to this blurred bucket that you've created as well as your output bucket. And so that ends up uploading it creates a new file into that second bucket that you've specified. Okay. So I sort of like you to understand all the code that you deploy. That's why I did the walkthrough, because I don't want, mechanically doing all the steps in the lab doesn't really help you as much as walking through and really understanding that you could build something like this. Are there any questions about what actually is being executed when you do this lab? Are we good? Okay. And then it's all a matter of deploying the thing. So again, I want to set the environment variables to make sure that the output bucket name reaches my function. I'm saying I want to trigger on a bucket event, and that actually gives me a certain request parameter call for my cloud function. And then I'm registering the function blur offensive images. So I'll do the deploy. And then you find an offensive image. So this one is a flesh-eating zombie. And then you do a wget to pull this image into Cloud Shell. And I hope that thing is still there. If not, find another. I just watched Zombieland 2. Hopefully, yeah, you search for that, and then maybe a Deadpool movie that might do it. Images from Deadpool would probably work. Actually, if you're having a hard time, post on the channel, and I bet you we'll crowdsource. We can figure out images that would actually cause the thing to blur. Definitely avoid the adult images, obviously. Like my TA, my TA probably doesn't want to see those. She really likes horror movies, though, so definitely go for the gore for your homework. We don't want to see, no adult images, all gory images is fine for this lab. And then just copy that file to that bucket, and that should trigger the event. And then you should see, in that other bucket, you should see the blurred version of this show up on the other side. And then you can, this part is, hey, I've deployed a cloud function. How do I get visibility in terms of what it's doing? You have to pull the logs files. So this is basically stack driver kinds of stuff where you're just going to see what is the output of this function, because you don't get access to the machine that the function is running on, right? So that's what this is for. Okay, and then clean up. That's the link to the lab. And then delete the function and the storage buckets if you'd like. Okay, the last cloud function ones, there's also an AWS Lambda lab after this. But the last cloud function one is the Slack app. So this Slack app will create this, will interface with the Google's Knowledge Graph API. So this is the application flow. So within your Slack channel, if you execute a /kg, so the /kg is going to be a custom Slack command that we're going to implement. And if you give this some search term in your Slack channel, then what you want to have happen is that request is going to hit a cloud function. And the Slack and the cloud function are going to share this verification token. Because you don't want anybody to just invoke your cloud function. You want a particular application. And so Slack has this notion of API tokens that you can pass along to mutually validate this. This is like a shared secret key. So if you remember the encryption thing, you're establishing a shared secret key so that only this particular Slack workspace can call this particular cloud function I have on the back end. So that's what this token is doing. And then from this cloud function, the cloud function is going to then, it has an API key to access the Knowledge Graph API. So same thing, shared secret between Cloud Functions and the Knowledge Graph API. Whoops, wrong direction. And so then it queries the Knowledge Graph API, and this is going to Google's backend, their search backend. And so when you say /kg Portland State, it's going to search Google for the top result for Portland State, and then the Knowledge Graph is going to send back the result. So that's why we're using Knowledge Graph. Knowledge Graph performs the query, returns the result, and then, in this case it's Stonehenge, not Portland State, and then it will push a message back into the Slack space that's got the result of that search. Okay, so this is all being done with Cloud Functions in this lab. Okay, and then you see the formatted response. So that's what this lab is for. The basic API call is going to, so your Slack instance is going to, and you could actually do this from within your shell, like a Cloud Shell or within a VM. Once you have deployed your function, then you can hit the endpoint, which is this KG search thing, and you can hit it with your Slack token, and then you should be able to get a response, just for testing. And so in this case, I send the token to my cloud function, and then I say I want to search for all results that are the top result for giraffe is what I'm looking for in this case. Okay, so this is how it's implemented. The first thing is to import all the packages. One of the things that's really interesting here is this API client library, and I'll talk about this in a second. The first thing that this thing does is it reads this config.json. this config.json has your credentials. It has your Slack token, and it has your knowledge graph API key in this file. This is actually insecure. You don't actually want this in the file system, because if someone gets access to this file and they're like, oh, I have all your credentials, typically you would pass this in as environment variables, just so that it's not sitting around in the file system. So some of these labs, you can see how we pass in environment variables. In this particular one, it's allowing you to either set it as an environment variable or as inside of this configuration. So when you do this open, it'll set this basically this dictionary and then set the API key. And apparently this is broken. I think Chris found that, and I put this in the lab. If your API key is set to null, this is going to break because it's going to say null API key and it's going to give you something invalid. What this is assuming is that your API key environment variable is properly set or it's undefined. So he was running the lab and apparently this was breaking. If you want to, you can just get rid of this part. If this thing breaks, just get rid of all of this up to the or, and then I hope you're good. And then we'll have to do some group debugging on this if the thing is broken. I just wanted to give you a heads up on that. I don't want you to spend hours on this thing debugging it. That's not the intent. Okay, so this is the endpoint, KG search. And if you look at it, it's only requesting posts because you have to post the search terms and the Slack token has to be there. So the only way you access this cloud function is through a post. The other thing is, the next thing it calls is verify webhook. So this is where that token is validated. Make sure that the token that you're getting onto this endpoint matches the token that you register as part of this cloud function. And then if it checks out, then what you're going to do is you're going to call the make search request with the text from the post. So this is basically taking the form data, the text field of the form data, and then saying, hey, this person wants giraffe. So this is your search term that's getting sent. And then you get a response, and then you return a JSONified version of the response, and that's what Slack is then going to parse and then give you a message on the Slack channel with. Okay, so if you look at verify webhook, it's really simple. It's just looking at the token field and making sure it's equal to the Slack token that's pre-configured just for validation. And then make search request is basically calling the API with the search term, with the query term. And then it executes that API call and then formats this Slack message. I'm not going to show you this. This is all just data marshaling this particular function to get it back into a format that Slack will display nicely. What I actually wanted to point out, which I failed to, is the way this works. So typically what you have seen before when you're using Google and Python is that, hey, I should import from google.cloud, import data store or import vision. If you look at what's going on here, it's like, hey, I'm just importing this API client package, and I'm using this thing called discovery.build. So what this is actually, and this is where things are moving towards, rather than forcing you to build these packages inside of Python packages at runtime, or at pre-runtime, where you're doing pip installs, what API discovery does is it dynamically builds you a Python object based on a specification of an API. So what this does is that this allows Google to update their APIs without forcing everyone to pip install new versions of their Python packages to leverage the new API features. So this is the new style of interacting with backend services, is to do a API client discovery build and create a Python object here that interfaces with the Google Cloud Platform. So there are two ways, and we'll get to this next week when I talk about REST APIs and calling these things. This is the newer way of instantiating code that you can call the backend with. Forgot to cover that. Okay. So these are the mechanics. You have to enable the knowledge graph API. And so one of the things about these labs is that you're getting through the mechanics of finding an API enabling it, and then using it and integrating it into an app. This is what your final project is about. If you get enough practice doing this, then you have hundreds of APIs to choose from. You can go wild. You can put anything into your app. Just use the same kinds of techniques. So this is sort of the build-up for your final project. So you just enable the knowledge graph search API. You create the credentials. So you have to create the API key that your cloud function will use to authenticate to the knowledge graph backend, so they can do the billing. So your API key is going to, because everything's going to be charged. It might be under the free tier, but they have to, the knowledge graph API backend folks need to be able to charge a cloud platform account. So when you generate this API key, this associates your cloud project with all the requests that this thing is going to make to the knowledge graph API. And that's typically done for any API that you're going to use. Like if you use a third-party API, you'll typically have to get an API key from them so that it can associate your usage to your email address or your account, your credit card is what this is doing. Okay. You're going to need to keep this open. When you create this API key, keep that window open because this is what you're going to have to cut and paste into your function. And then you're going to go to Slack and create your own workspace. We're completely full on the PDX Slack workspace, so you can't put your bot in there. So you create a new workspace of your own, and then what you're going to do is you're going to create an app in your workspace. And when you create an app, you just name it like CS410 bot. This is the name of my workspace, so you'll have whatever workspace you created there. And then within that app, you go into basic information and you figure out what your verification token is. And this is the shared secret. So anytime this Slack workspace is going to make or this bot is going to make a request anywhere, it's going to provide this Slack token as the authenticator. This is the thing that you have to copy and put into your cloud function to validate that the requests are coming from Slack. And then you clone the repository. It's probably already there. You go into here, you edit this config.json, the verification token in the last slide, the API key from 2 slides ago, and you update config.json with both of those things. So to make the app work. And then you deploy KG search from that directory. It's a HTTP trigger. It will give you this trigger. And now what you need to do is you need to register this trigger on your Slack bot, on your Slack integration, because this is now the endpoint that is going to be called whenever someone does the /kg command. So the next part is to go back into Slack and configure the / command. So in this case, you're going to create this new command, /kg. You're going to say all of those requests will go to this URL, which is from your previous endpoint. This is the knowledge graph thing, and then save this Slack command, and then install it into the workspace, and then authorize the app, and then finally, in your Slack, do a /kg of some search term, and hopefully you'll get something that looks like this. And this is what I want you to screenshot for completion of this lab. And then you can also look at the logs, just like before, to be able to debug your cloud function. Okay. All right. The last thing you're going to do is the Lambda. I'm not going to walk through this because this is basically the hello world of Lambda. It's similar code. It's very trivial code, so I'm going to skip that and then take any questions that people might have because if there's time, hopefully there's some time for you to just get started. Oh, sweet, 30 minutes. So the rest of the time is yours to work if you have brought anything. All right.